So we stopped with linear momentum. I mean, with projectile motion. In other words, you're saying that we stopped somewhere here. We stopped somewhere here.
Yes.
Okay. Non-uniform acceleration, including use of graphical methods. And this is not so important. We shall look at it later on when you're looking at simple harmonic motion. So meaning that when we were to start, we should start with this. We should start with this, and so on. That is in mechanics. At one time, you said that you're looking at some videos on YouTube. Did you look at any of these?
I wasn't looking at new things.
You're looking at all the old things, eh?
Okay, maybe paper 2, these things of waves. Yeah, maybe I saw some new things.
Okay. Okay, it's okay. No problem. Then, if you look at heat, you looked at temperature, looked at the different types of thermometers, looked at heat capacity and specific heat capacity. You didn't look at, did you look at the method of getting specific heat capacity using the method of mixtures, cooling correction?
We just wrote notes from home.
Yeah. So you didn't have anything like a calculations?
We had calculations for thermometry, for physical things, properties.
Thermometric properties. So for heat capacity, didn't have like calculations?
No.
It's fine. It is fine. It is fine. Okay. So when we meet, we shall be looking at momentum, and then afterwards we shall look at we shall be combining them. We shall get a way of looking at this. At the moment, let's look at mechanics. Maybe tomorrow we shall look at heat. Maybe the other day should go to paper 2 like that. We shall discuss as time goes on. So to begin with, just get this document here. I'll be sharing this document here. Okay. Oops. Let me just get something to discuss, something for us all to discuss. We stopped with projectile motion. Do you have any pamphlet, any textbook of physics?
No.
Okay. I'll see what to do. It's going slow. This is momentum. You're supposed to begin with momentum, right?
Yes.
Okay, momentum. Momentum. We normally represent momentum using the letter P, like that. Momentum. Okay, to begin with, what do you remember about momentum? I know you looked at it in O level, senior 2 there, senior 2 physics. What do you remember about momentum?
It is the product of mass and its velocity moving in a straight line.
Okay.
Then I remember the law of momentum.
Conservation of momentum.
Then we talked about bullets, yes? Then bullets, those questions. Then there was elastic and over inelastic. That's collision. Yeah?
Yes, that is true.
That's what I remember.
Okay. No problem. I would have showed you a video here, but then I will, I think, show you next time when we meet about momentum. Anyway, whatever you remember is very important, because whatever you remember is what you're going to be using to build on as far as this lesson is concerned. So to begin with, momentum, you've said that you remember that momentum is simply defined as the product of mass and velocity. That is correct. When you add on the word linear momentum, it is almost the same thing, just emphasizing that when talking about momentum, always take it that we're looking at something in a straight line. Momentum, linear momentum, in other words, it is the product of mass and velocity of a body moving in a straight line. In other words, when you're dealing with questions involving momentum, we can have momentum in 2 dimensions, that is the horizontal component and the vertical components. We'll look at that later on. But when we're treating each of them, we always look at one at a time, each one in a straight line. First of all, in the X direction or the X axis, and then the Y axis separately, and then maybe we look at something else connected to that question there. So let's begin by having this, a question here. By the way, in a layman's language, the word momentum simply refers or means the quantity of energy. Of course, don't write this as per now, just for a layman's language. In case someone asks that, what do you mean by momentum exactly? So in a simple language, momentum simply means quantity of energy that a body has, or simply the amount or the quantity of inertia in a body. But when I talk about momentum in physics, we always look at mass and velocity of a body. Now, someone may ask that, why do we look at mass and velocity? What is it all about mass and velocity? It is just very simple. Assuming that you have two bodies. We have a small body here. Let me assume that maybe we have an orange. And then maybe we have like a jerrycan, like that. Now, if this jerrycan is made, okay, let's assume it is empty. When you throw this orange towards the jerrycan, does the jerrycan fall down or it remains standing? Yes? Yeah, on and off. If the orange is thrown and then it collides with the jerrycan,
And the jerry can is empty.
Yes.
No.
It doesn't fall.
Yeah.
Okay. The question is, does it fall? Doesn't it fall?
The jerry can or the orange?
The jerry can. We're looking at the jerry can. The orange is thrown and then it strikes the jerry can.
Yes, it falls.
How about if the jerry can is full of water?
It doesn't fall.
Okay. Another question is here. If you have a bullet, you can imagine the weight of the bullet or the mass of the bullet, assuming that maybe it is 10 grams. If it comes and strikes a human being, does that human being fall down, or does he or does she move a little bit? In other words, you're looking at motion. Does the person move a little bit? In other words, falling, or she doesn't, or he doesn't?
Yes.
The person falls down. Okay, I'm driving at something here about mass and velocity. Yes, when you saw this orange here, when you saw that orange there, if the jerrycan is full of water or if the jerrycan is empty, it may fall or it may not fall, depending on two factors. One, the velocity of the orange. If the velocity of the orange is very slow, then it is most likely that the jerrycan may not fall. In other words, as this orange is moving, it is having little quantity of energy. That's what I'm driving at. So if the orange is having a very high speed, if it is thrown with a very high speed, it can easily make the jerrycan fall down. Just like how a bullet, which is moving very fast, when it strikes the human being may, of course, move off the ground. I mean, as in the person may fall down or may at least stagger. In other words, the bullet causes at least a change in the motion of the human being. Why? Because of velocity. So meaning momentum or the quantum of energy possessed by a body, that momentum is directly proportional to the velocity of the body. At the same time, in case you have a small car and then you have a very big car, if these two are moving and the brakes are applied at the same time with the same amount of braking force, we find that this small car tends to come to a stop very fast. At the same time, the vehicle, the big car or the trailer takes a long time to come to a stop. In other words, it even covers a longer distance. Why? It is because the bigger car is having a bigger momentum, a bigger quantity of energy. In other words, momentum is also directly proportional to the mass of an object. So when you combine both of these, momentum is proportional to the mass times the velocity of a body like that. And therefore, you can simply come up with an equation that momentum is equal to mass times the velocity of the body, whereby the constant of proportionality is always equal to a 1. It is found that it is equal to 1. That's why we come up with this equation here. So in short, we can simply, let me first rub off this. You can simply write this very fast. By the way, I didn't want to give you time to write down. You needed to write down your own notes concerning momentum. I didn't want to give you notes, anything like that, because it takes a lot of time. But this is what I wanted us to write. Let me just show you. As we're discussing, you should be noting down the important points. So for example here, the definition is simply say that momentum is the product of mass and velocity. That in other words, momentum is equal to mass times velocity, like that. And then number 2, what is the SI unit of momentum?
Kilogram meters per second.
Meters per second, correct. And then you know that momentum, we need to note that momentum is a vector quantity.
Yes.
Momentum is a vector quantity that has both magnitude and direction.
And direction.
Yes. So let's have an example here. Oh my word, go on. What is wrong, but it is okay. Just a moment here. Just a moment here. I just want to bring back my work. Okay, it is now back, hopefully. Yes, can we see that? Can you see anything on the screen?
Yes.
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 All right. So we define momentum as a product of mass and velocity of a body. That is what we have here. That's what we have here. It is the product of mass and velocity of a body. In case you add on that moving in a straight line, that is also very okay. We don't have any problem with that. So I just wanted us to look at some of the examples here. Let me just write here examples. You try them out for me. Calculate the momentum if part A, the mass is equal to 2 kilograms, velocity is equal to 2 meters per second. Get me the answer here. Yes, we have 3 questions here, part A, part B, and then part C. What answer have you got here?
For part A, I have 4 kilogram meters per second. And for part B, and for part B, I have 25,000.
25,000. All right. So in other words, you needed to change the mass to kilograms. In other words, 2.5 ton is equal to 1,000 times 2.5, which gives us 2,500 kilograms.
500.
All right. Therefore, that means that our momentum is equal to mass times velocity, which is equal to 2,500 times 10, which gives us 25,000 kilograms meter per second. Okay, then part C.
I hadn't seen part C.
Yes, it is here.
Part C, I have 3,600.
3,000?
600.
600. All right. Okay. What is this one? What is the mass of this in kilograms?
That is 50 divided by 1,000, 0.05.
0.05 kilograms. And then this one in meters per second.
Hey.
So the same as 72 kilometers out of, this is per hour, sorry, out of 1 hour.
Yes.
It is the same as 72,000 meters divided by 3,600 and get 20 meters per second. Therefore, our momentum is equal to mass times velocity. You continue and get the answer. Like that. Like that. Okay, let me remove this. Okay. The other parts are missing, but it's fine, it's fine. It is fine. It is fine. Let me first check again. Other parts may be there. Yes, this is where we are. Okay. Okay. So after having looked at that, you can be making some notes as well there. We have the term impulse. What is impulse? By the way, the other question that I've left that are you hearing me? Yes, are you hearing me?
Yes.
Yes. The other question which I left out was that, of course, I just ignored it, thinking that you've got it, but let me just ask it and I find out what you can write. So the question says that we have two vehicles, one A and then another vehicle B. This vehicle is of mass maybe 1.0 tons, and then this vehicle is of mass 15 tons, like that. If these two vehicles are moving at the same speed, 10 meters per second and 10 meters per second, and a braking force is the same braking force is applied to both of them, which one comes to rest first and why?
Which one comes to rest first?
And why?
They don't collide.
No,
they are moving at the same speed.
Yes, in the same direction at the same time. I can just give you an example here that if this one is 15 tons, they can say, for example, maybe a fuso. I'm just giving an example. Or a trailer. And then this one can be like a saloon car. Yes. Which one comes to rest first and why?
A.
Yes.
Because it has it has less mass.
Correct.
Therefore, the momentum is less. How should I say this?
It is correct. Go ahead.
I stop there.
Yes, they first tell us that since they're having the same velocity and A or B is lighter than A, then B has a less momentum than B, sorry, than A, and therefore it comes to rest faster. And that is the reason, just that. You just need to identify that B is lighter, it has less momentum, and therefore comes to rest faster. It covers a shorter distance. Okay, so that is fine. Now, after having looked at that, we have a term called impulse. What is impulse? Of course, in biology, it has a different meaning. In physics, especially in motion, it has a different meaning. In physics, it is simply defined as the product of force and time. You must add on this statement here, for which the force acts on the body. That is what we call impulse, or simply put, as the change in momentum of a body. That's how we define momentum. You can just quote it somewhere there. Impulse, it is the change in the momentum of a body, or it is the force, it is the product of the force and time for which the force acts on the body. And how do we come to this? We simply say that from the second law of motion, in other words, from F is equal to ma, our force is the same as mass. Remember that acceleration is the change in velocity v minus u out of the time t. Now, if you cross multiply here, we shall end up with our force times t equals to mass times v minus u. And this is the same as ft, which is the same as mv minus mu. So from here we can note that this fv mass times the final velocity gives us the final momentum. This one gives us the initial momentum. And that's why we are saying that the term impulse is simply defined as the product of the force and the time for which it is defined as the force and the time for which the force acts on the body. That is impulse, the product of the force and time for which the force acts on the body. Or simply put, change in momentum. So you can quote this as well. You can quote that as well. So after having looked at that, there's this example here. Hope that I can rub off this. I need you to respond such that I know that we are moving together. Always keep yourself animated.
Yes, okay.
Right.
There is some noise in the back.
I'm not hearing, it is fine. So
there is some noise.
It is, I can't hear it. We can simply go on. Okay. So after having looked at that, I said that it is better that you quote this, that from impulse is equal to force times time for which the force acts on the body, or it is the same as the change in momentum, v minus u, like that. And you've seen how that equation comes about.
Yes.
Yes, actually it is even here, it is even there. Okay, so another part, after having looked at that, we can look at those examples there. We have this first example. We have that first example there. Okay, I wanted to skip some, but it's fine. We can go through them together. So the first example says that a body of mass 5 kilograms, initially moving with a velocity of 2 meters per second, when it experiences a force of 10 newtons, is 2 seconds. Find the impulse. There's something missing here. Time is missing. When it experiences a force of 2 newtons in 2 seconds. Maybe this one doubling in 2 seconds. Find the impulse. In other words, impulse is equal to force times time t, which is here. At the same time, they're saying that find the velocity of the body when the force stops acting. In other words, the final velocity. So from our F equals to m into v minus u out of t, we have already got our impulse, which is ft, which is equal to m v minus u. So our impulse here is 20 Newton seconds. It is here, 20 Newton seconds. This is the same as the mass, which is 5 kilograms into v, and the initial velocity is 2. That is what we are having here. So when you divide both the sides, divide by 5, it will give us 4 equals to v minus 2, implying that therefore that our final velocity of v is equal to 4 plus 2, which gives us 6 meters per second. That is how it comes out. That is how it comes out. It's very simple. It's just the same thing as what you looked at in our O level. I'll send you this document. At least maybe you can just maybe follow, or you can even write down something. We have 13 minutes. Okay, number 2. I'm interested in number 3, most especially. Number 2 says that a body of mass 50 kilograms jumps onto a ground from a height of 2 meters. Calculate the force which acts on him when he lands. Maybe there is a common question here, and actually it is even practical. If you are to jump from maybe the window level, I know you've ever jumped from the window. You're very stubborn. I'm joking.
No.
Anyway, I'm joking. Assume that you have to jump from a given height.
Yes.
Yes. Would you prefer to fall on a soft ground, maybe like where sand is? Or you would prefer to fall on a hard surface, maybe like the floor of the house?
A soft ground.
Yes. Why?
Because soft. Okay, the pressure would be less.
The pressure.
Over. Yeah.
Don't bring in out of physics terms. Just give me a clear reason.
No, that's because you feel less pain.
Yes, very good. Because you feel less pain or you feel less injury. That is very good. That is very good. Now, after telling me that, then the question is, how does it come that you won't feel pain? So that is the question now. Actually, you write it down somewhere. Explain why a high jumper prefers to fall on a soft ground and not on a hard surface. That is what you just told him, and not on a hard surface. I can give you 3 marks here. I can give you 3 marks. So the reason or the explanation, you can simply say that the high jumper feels less pain when he or she falls on a soft ground. On soft ground. So that is what you've just told. Now the question now is, how do you explain that? Of course, when I'm marking you, I'll give you a mark here. Then I'll ask a question that, why do you say so? It is all coming from the word impulse. It is coming from the word impulse. Now, how do you explain that? This is what we are going to say. That from F is equal to M into V minus T, sorry, V minus U, V minus U out of T. Are we there?
Yes.
I.e., if M is a constant, the final velocity is a constant, the initial velocity is a constant, then it implies that our force F is inversely proportional to T. What does that statement mean? That F is inversely proportional to T.
It means that maybe as force increases, time reduces, something like that.
Yes, that is correct. In other words, as the time increases, the force reduces. So this one here implies that as the jumper, you can write this as the jumper, but they can use it properly. Can you see?
Yes.
Okay.
Yes.
Okay. As the jumper falls on a soft ground, as the jumper falls on a soft ground, it takes a longer time for him or her to come to rest. This in turn creates a less or a smaller force. This in turn creates less force, force of impact, and so feels less pain. The reverse is true. So that is what I would say. I'll first give you this mark here. One mark. I'll first give you this mark here for less pain. Then I give you a mark for this equation here, n of these two, n of those two. And then I'll give a mark for this one here, takes a longer time. And then
For him to come to rest.
And then less pain. So that is what I would say. Now, are you done with that?
Yes.
Yes. A similar question would be this, that explain why a person jumping from a given height bends his or her knees. Of course, it comes naturally. It is automatic. Someone jumping from a high ground has to bend the knees a little, or depending on the height, the person bends more. Or another may ask that, why is it that the goalkeepers or those ones who play baseball, when that person is catching the ball, who's the one who's catching a ball in a baseball game or in a cricket game, the person draws, or even the goalkeeper in a football game, the person draws his hands backwards as he's catching that ball. The person moves the hands from the front going backwards as the ball is catching that ball there. Why is it so? It is the same reason here. To create less pain. And what is creating that less pain? It is because as the person is grabbing that ball, it takes him a longer time to make that ball to come to a stop, to come to rest. So as the time increases, the force of impact reduces and therefore less pain. So that is what you can say about impact. Okay, so number 3 is here. Number 3 says that a ball of mass 0.25 kilograms moving in a straight line with a speed of 2 meters per second strikes a vertical wall at an angle of 45 degrees. Anyway, this is the solution here. This is the solution. I'm going to explain it. At an angle of 45 degrees, the wall gives it an impulse I in the direction of the normal, and the ball bounces at an angle of 60 degrees to the normal. It is here. 60 degrees to the normal. Then calculate the magnitude of the impulse. In other words, you've said that impulse is equal to force times the time of impact. That is what we have to do. This time here, I have to emphasize here, this time here is the time for which that ball is still in contact with the wall. It is not the time of the ball coming and going, no. It is the time for that ball to be in contact. Now, if that is the case, then how do we calculate the impulse? Now, we can see this, that this, we are having the first component here, which is the velocity. It is coming at an angle. We can call this on our initial velocity u, and then it is going away with a final velocity v. Yes, with a final velocity v. Meaning that from our f is equal to ma, our a is the same as v minus u out of t. And therefore it means that we shall have to look at this velocity here. In other words, f times t, which is equal to the impulse, is equal to mass times the final velocity, then minus the initial velocity, like that. So in the question we have the mass, we have the initial velocity, but it is at an angle, which means that we have to resolve. Now, as we're resolving, we need to remember what we looked at under resultant of vectors. This is what we had. It is almost time. This is what we had. We said that anything which is going upwards, we shall give it a positive. Anything which is going downwards, we shall give it a negative. Anything going in the positive x direction, we shall give it a positive. And anything going in the negative direction, we shall give it a negative, like that. So for this one here, we are having two components. One is horizontal, which means that we shall be having our u resolved to the horizontal like this, at the same time to be resolved to the vertical, like that. Likewise, I had lost you, sorry. Just a moment. It is fine. Yes, I had lost you. So we are having, because I draw on this same diagram here, we are having this and then this. So when I resolve this one upwards, it will be, if this is the initial velocity u, this is the final velocity v, I'll be having my u as sine of 45. Then when I resolve it horizontally, it will be u cos of 45. Do you remember that?
Yes. Yes, teacher.
Okay, if that is the case, then what will be this one be equal to? When I resolve this one to the vertical, downwards.
V sine 60 degrees.
No, 60. And then when I resolve it to the horizontal, it will be v cos of 60, like that.
V cos 60.
Yes. Okay, so if that is the case, then we shall say that, of course, this one is going to be a positive. This one is going to be a negative. This one is going in this direction, so shall give it a positive. And then this one is going in the negative direction. It is going this way. Shall give it a negative. Like that.
Yes.
So shall say that horizontally, shall have our impulse capture the magnitude of the impulse. Okay. So impulse is equal to mv minus mu. So horizontally, we shall say that our impulse horizontally is going to be equal to mass, which is 0.25 times the velocity, final velocity, which is negative, times negative v cos of 60, then minus 0.25 times our u, which is u cos of 45, like that. And remember that our impulse is the same as force times time. Force times time. So this is for horizontal. Then you do the same vertically. Vertically, we shall have a 0.25 times the final velocity is going in the negative direction. This one here. Times v, this was, yes, v, a sine of 60, but negative. Then minus 0.25 times u a sine of 60. Like that. So once you have done that, in other words, what I wanted you to see here is this one here. This one here. How to resolve the velocity. That is the most important thing that I wanted you to see. How to resolve those. Then afterwards, use that equation there. Let me move upwards here and show you. Are we seeing that?
Yes.
Okay. So we see that our impulse horizontally is equal to 0.25. Final velocity was v cos of 60 minus, this one was a negative, times negative, then minus 0.25 u times positive u cos of 30, was it 30 was 45, if I'm not mistaken. It's like that. So when you simplify this, we shall get this. Do the same vertically. We shall also get another equation. And so when you solve them, you'll find that your I will be giving you 2.23 Newton seconds. And that will be our final answer. That will be our final answer. Let me send you this document on WhatsApp. And you studied it very well. When we meet again next time, we shall be looking at collisions. I've already explained this to you.
Okay.
Yes. So read it through. Just go back to page 60. Just go to page 60. You'll find it there. I'm going to send it in now. So when you find any challenge, please